Yeah, I think we are good to go now. So hi once again, and hope everyone is doing well and staying safe at their places. So I warmly welcome you all to the second episode of the AWS webinar series done by the T and Tech Innovative in collaboration with the AWS Focus Group at 99X. So if you're into AWS and want to be hero from zero, this webinar series is going to help you a lot in a massive way. So if you have missed out on the first session or the previous session, you can go to our YouTube channel and check out the link of the recording there as well. So this webinar series contains of 4 sessions, and the main topics that will be covered are introduction to serverless computing, which happened last week, and then AWS Compute Services, which will be happening today, and then the upcoming sessions will be on data store services, application integration services, and application integration services. So these sessions come with practical demos where you can do hands-on sessions with the speaker and ask about anything, like if you get stuck on a point as well. So in today's session, you will get to know what exactly AWS compute services are and how we can utilize it. This webinar will also explore the basics of AWS compute services and look at some of its use cases in depth as well. So thank you for joining us with this session. And if you have any questions, you can drop it in the chat and we'll be answering them in the Q&A session at the end. So as a speaker for today, we have Rahal Madhavata, who is a senior software engineer with more than 3 years of industry exposure with significant design and development experience with AWS. He has designed, developed, and deployed several production-ready applications on AWS and cloud. He is also he's passionate about web development and believes that the cloud is the future of computing services. So without wasting much of time, I warmly welcome Rahal to take over the screen and go ahead with the session.
Uh, Thank you very much. So, hello everyone, good evening. So, we are going to talk about AWS Compute Services today. I hope you can see the screen.
Yeah, it's visible.
Ishrat? Yeah, okay. All right. Before we begin, I have to give a little introduction about compute services. So, we will have a look at the agenda in a bit. So I'm Rahal. I'm a senior software engineer at 99X. I have a significant amount of AWS exposure. So I'll be focusing on today and trying to give you a high level understanding of AWS compute services and what compute is, cloud computing, and as well as how AWS compute services work well with each other and when to use and when not to use some of these services. So uh, uh, keep in mind that this is a very high level uh, explanation that I'm going to give you. If you need an in-depth knowledge on it, you can further research or reach us at 299X then we can assist you in that. All right, so let's have a look at our agenda for today. So we have first of all, we will have to look at what is AWS Compute Services. So in order to get there, we will have to look at what is compute and what actually is cloud computing. So you may have heard this term throughout the entire, if you are working in the industry, you might have heard it throughout the entire industry experience. And also if you're in the university, you might have heard what is cloud computing. And so I will be touching a little bit on that, for those who don't know. And then we are going to get a general understanding of the following services that AWS offer with regard to compute services that AWS offer. So we have Amazon EC2, ECS, Lightsail, Elastic Beanstalk, Lambda, Fargate, Aprana, and lastly EKS. So it may sound gibberish to you if you don't know about AWS services. All of these names might sound very complicated and very harsh towards the beginners, but don't worry, these are just names, okay? And if you get a little bit of understanding of what they are, these names actually make sense and you can actually be comfortable with these names. And as soon as you hear a name, you will know what this is. So that kind of understanding is enough in the beginner level. So that's what we are trying to do today. All right, so without any further ado, let's move on to the first uh, topic, what is AWS Compute? So before jumping onto that, I want to share what actually is compute. So in you might have heard what compute is. So in cloud computing, the term compute describes concepts and objects related to software computation. So basically what it does is it does software computation, but where it does is the problem. So usually it happens on a server. So where is the server is what defines cloud and not cloud. So usually you don't hear the server in cloud computing a lot. It is referred as cloud or instance in some cases. So it is a generic term used to reference processing power, memories, networking, storage, and other resources required for the computational success of any program. So these terms that I mentioned, processing power, memory, networking, storage, all of these are known as computational resources. So we will look further into this because these resources are mentioned throughout this entire presentation. When you are talking about performance, when you're talking about resource handling, all of these, processing power, memory, networking, all of these come into the picture. And then we have cloud computing. What exactly is cloud computing? It's basically light computing, but through the internet. So that's the basic understanding of it. Cloud computing is a generic term for anything that involves delivering computer resources over the internet. So the resources that I mentioned earlier, processing power, memory, storage, if those are delivered across the internet through to you, then that exactly is cloud computing. So there's not much to it. So if you hear the word cloud computing, don't get scared of it. It's actually nothing much. It's uh, just like a physical server, but it's you actually don't see it and you actually don't interact with it like physically. That's the basic difference between just having a server and cloud computing. So that's about it. And users can access large amount of computer power on demand. They can purchase by the minute or the hour and use as much as little as required for their computing activity. So this is the new trend of it, the on-demand computational power. So we will talk a little bit more on how they are going to use it and uh, what kind of pricing model that they have. So it differs from service to service. So usually what here, as I mentioned, it is purchased by the minute or the hour, the computational power. So yeah, that's about it. So this is what cloud computing is. So AWS Compute Services are basically these cloud computing services that AWS offers. So there's nothing much. AWS, you might have heard, is one of the biggest, if not the biggest, cloud vendors out there. So their offerings regarding this computational services are AWS Compute Services. So that's basically the definition of it. So there are so many AWS Compute Services available. So I have listed down the most popular ones, and I will give you a brief summary on each one of them. So Amazon EC2, ECS, Lightsail, Elastic Beanstalk, Lambda, Fargate, AppRunner, EKS. So all of these services are compute services of AWS. It's actually very with the sophisticated AWS services, it's very hard to define a fine line with compute services, data storage, and app integrations. But some of these overlap with one another, but these are basically the compute services that there are. Okay, let's talk about the first one, Amazon EC2. So the name itself is kind of very technical. It sounds very technical, EC2. So that's the abbreviation. You can expand it. That is Amazon Elastic Cloud Computing. So the name itself is very understandable. Amazon Elastic. Elastic, what does it say about an elastic? So whenever you hear a word elastic, it's like very, you know, it's very expandable. It's the expandable word is there itself. So that's what EC2, the main attraction of EC2 is the expandability of it. So we will get there. We will talk about it more. So Amazon Elastic Cloud Computing is what EC2 is. So Early days, in early days, the when you want to deploy a website or a web server, web application, then what you need to do is go out there, have to buy a server, a computer, basically a computer, another with CPUs and GPUs if you need, and RAMs, memory. All you need to you have to go and buy and then take it to your premise and then set it up, install everything, and have it there physically. Then you have to manage it physically. So that's how it has been like 10 to 15 years back, right? So that is a compute service. That is not cloud. That is a compute service that the person is going to run. But the problem with that is you can almost imagine how difficult it might be to actually maintain, to scale. Like if your website is popping off and then there are so many traffic the coming in, and now you need to scale it, scale scale out. So what you need to do is go out there and buy more and then set it up. So it's a very big hassle. So to avoid that, we can use this Amazon EC2 services. So what it does is without having to manage your servers physically, they provide you servers. We do not call it servers in EC2 cases. We call it instances because you're not allocating a server per se for a client. We are allocating, the Amazon is allocating an instance. Maybe it can be a part of the server. It can be part of two servers. So likewise. So what it basically does is it's giving you a part of this server, and then it's allocating you to it. So it's pretty simple. You don't actually see the server. You don't have to maintain it physically. They are maintaining it, so you don't have to worry about the infrastructure physically at all. So it's a virtual cloud infrastructure service that provides on-demand computing resources. So that's really great. Is the word on demand is highlighted here because virtual cloud infrastructure service that provides on demand computing resources. So the more you need, the more you can get. That's basically it. But you have to pay for what you are getting. But it's very, very easily scalable. So that's why the elastic term elastic comes as well. So it's very, very scalable, meaning that you don't actually have to worry a lot about scaling and the overhead of scaling when needed. Scale in and scale out, both you can do pretty easily by EC2 instances. And it lets you avoid the hassle of maintaining servers physically. This is one of the most popular AWS offerings as well. It mainly consists in the capability of EC2, that is renting virtual machines. And then you can collaborate it with the EBS, Elastic Block Store, storing data on virtual devices. This is a storage service, and also distributing load across machines, Elastic Load Balancer. That meaning that whenever that you have a very huge load inside a EC2 instance, then it becomes a problem. So you can have load balancers to balance out your traffic. And then there are scaling the services using an auto scaling group. So with this auto scaling group, you can easily scale your services up or down anywhere you want using this ASGs. So it's pretty easy when you are comparing it with physical servers. So you don't have to worry about the infrastructure at all, physical infrastructure at all. You can just use any one of these services that suppose this EC2 on top of it. So if you have actually participated in the last week's serverless webinar, then Vindhya actually talked a lot more about these EC2 instances and how ELBs can be used, and how these ASGs. She was talking about the advantages of serverless as well as the disadvantages of EC2. So there she mentioned all of this. So I have to tell you that this is a server full service, meaning that it's not serverless. You have to worry about your server. You have to worry about your managing your server as well, but just not physically. So that's the main advantage of EC2. Creating an EC2 instance is pretty easy. You have to choose one of your region for your instance, and then you have to choose your AMI. Just like your physical machine, you have to choose the uh, you have to choose the OS, the operating system for your instance, and then you have to choose your instance type, like what are the processing power that you need, what is the storage that you need. So what kind of instance type that you need. With this instance type only, that you will that the the fee for your instance uh, will differ from one another. So, and then you have to configure your network settings and then configure storage. So I can quickly show you how it can be done. So if you go into this management console of AWS, yeah, this is pretty easy. You just have to create an account in your AWS, and then you directly direct it to this management console. So here you can manage all of your AWS services. So if you type EC2 here, you can go to that home screen. So here you will be able to see an overview of all your instances and volumes. Everything is there. Security group, snapshot, elastic IPs, everything is there. I'm not going to go into much detail. I'll just show you how you can quickly launch your instances. So this is, if you select that launch an instance, then you have the name, obviously, and then this is the AMI I told you about, the operating system of your server. So you can choose Amazon Linux, Mac OS, Ubuntu, Windows, anyone you want, and then the architecture. Then this is the instance type. So this is I have selected the free tier eligible, but you can go for any one of these depending on the computational power and the traffic that you're going to get. So this includes the pricing options as well as the memory, CPU, likewise. And we have the key pair login where you can identify, and then it makes things easier for the communication purposes. And then you have network, how we are going to communicate with the instance, so how to send traffic and what methods. And then you have the storage. This is the default one for the root volume that is there for the operating system, basically. So if you want more, you can add new volumes as well. And there are advanced details which I will not dig into. So this is pretty much it. So with the click of a button, without having to go out and buy servers, this is pretty much easy, as you can see. So you can just launch your instance just like that, and you can manage it however you want. So yeah, that is basically about EC2. Yeah, let's move on to the next one. So I'm going a little fast because of the time limitation. We have a lot of services to cover. So if you have any questions, just keep note or put it in the chat. So we'll have a look later on. Then we have Elastic Container Service. So I hope you get the understanding of what EC2 are and how easy it is compared to a physical server. So from there onwards, we are looking at how to make things easier on top of EC2. So that's what the first part of this presentation is all about. So in ECS, it's easier than EC2. So this actually, what ECS does is Amazon Elastic Container Service. So if you have a containerized application, you can use ECS to deploy it easily. So Amazon ECS is a fully managed container orchestration service that makes it easy for you to deploy, manage, and scale containerized applications. So if you have built applications such as Docker, if you have built an image, then you can easily use this ECS to deploy your containerized applications. So you can use it either with serverless, with Fargate, or you can use it with managed server full architectures like EC2 options. So we will talk a lot more about Fargate and when to use and when not to use it. And we have already talked about EC2 options. So you can use either one to deploy your ECS service, ECS for your containerized application. And then this supports auto scaling to handle variable volume. And also this is very cost effective with autonomous provisioning, auto scaling, and pay as you go pricing. So these advantages are there when you use ECS for containerized applications. And then when you're deploying a containerized application using ECS, it's pretty much simple. This is a very basic example that I have taken. So you can use this Amazon Elastic Container Registry to upload your built images build, let's say, a Docker image, build Docker images into this ECR. This is like a repository, just like GitHub, if you are familiar with it. If you are familiar with it, this is like it's a repository where you can keep track of your images. You can roll up, roll down, roll forward, roll backwards. Likewise, if you can use this to keep track of your images. So this is a repository. So if you, after you have uploaded your image into repository, you can point it at this Elastic Container Service, and then you can define your application, select the container images and resources needed for your application from this, and then you can use whatever the compute options that are there. You can use AWS Fargate, EC2, or anything that you desire. We will have a look at this Fargate later on. So just keep in mind that it's also another compute service, just like EC2, that we can use for deployment. And then you can easily manage your containers using ECS to scale your application and manage your containers for availability. So this is for containerized application. You can easily deploy without having to worry much about the infrastructure. So yeah, let's have a look at Amazon Lightsail. So I told you that even when I told you about the deployment going through the management console, you may have seen a lot of options are there. So either you can go through every one of them or deploy the basics. But even then, there is a bit of an overhead is there for managing your server, and you have to monitor it, you have to scale up, and in the security wise, you have to do a lot, because in the security wise also, who have access, who don't get access, and you have to create your VPCs and whatnot. So it's a bit of a kind of a hassle to manage a server. Let's say that you are deploying a very simple web application, but still you need to go through each one of these uh, to properly maintain and monitor your server. But what Amazon Lightsail does is to avoid that, an easier way to deploy and manage your instances. So this is very easy, very user friendly. So with like 2 or 3 clicks of buttons, you will be able to deploy your application. So a fixed price for the month. This is very important. So I told you in the EC2 instances uh, where we have to the billing is counted as on demand service, right? Meaning that the more processing power that you will need, the more processing power that you will use, it will cost you that. So if you have a very unpredictable computational power needs or very unpredictable traffic, then it might be a bit of a hassle to predict your cost as well. So what Amazon Lightsail does is to avoid that kind of hassle that you have to go through by having a fixed price for the month. So by having this fixed price for the month, if you select a particular instance type for you, meaning that this much of processing power is needed, this much of RAM is needed, then that price will be fixed for you. So it's your responsibility to utilize it properly, but that pricing will be fixed. So that is what's most important here. And also it automatically configures networking, access, and security environments. So you don't have to worry about those infrastructure aspects. And it is very easily scalable, letting you migrate to broader services such as EC2. So let's say that you have developed a very primitive web application which doesn't need any computational power. So you have decided to use it to deploy it using this Lightsail. And the more time it passes and it's becoming big and it's going to grow and you're going to more traffic, but the Lightsail can't handle that much of traffic, then you can easily, with the click of a button, you can migrate to EC2, where you have more configurational options and more computational power, more flexibility when it comes to EC2. So there is that option when it comes to Amazon Lightsail. So there is another option, just like Amazon Lightsail, we have AWS Elastic Beanstalk. So this is just like Amazon Lightsail, but with a little difference. So I'll tell you, AWS Elastic Beanstalk is an easy to use service for deploying and scaling web applications and services deployed with these particular languages. So it's very fast and easy to begin just like uh, Lightsail. It's very fast. It's very simple to begin with. Elastic Beanstalk. Before we go into this Elastic Beanstalk, I can show you how Lightsail looks like. Here you can see how user-friendly it is to deploy. Remember that the EC2 instance deployment window, and have a look at this. So Amazon Lightsail, if you create an instance, see, this is very, very easy. It's like very primitive way of deploying your service. You don't actually have to worry about anything, just have to worry about the basics, like what is your server location, platform, the blueprint that you're going to use, what is the architecture and the libraries that you're going to use, and then the monthly bill value. So it's pretty straightforward. You actually don't have to worry about anything, and this is the name. So just like that, you can deploy your Amazon Lightsail. So it's a very easy way of deploying instances. So yeah, so let's come back here. Elastic Beanstalk. Yeah, so Elastic Beanstalk is just like that as well. So it's fast, simple to begin with. Elastic Beanstalk automatically handles the deployment details of capacity provisioning, load balancing, auto scaling, application health monitoring. The monitoring is easy as well. So it's just like Lightsail. It's fast and simple to begin. And developer productivity is increased obviously with Elastic Beanstalk as well as Lightsail, because you don't actually have to worry about this infrastructure for servers or infrastructure for instances, because you can work more on the application level. So that's the productivity ultimately goes high. And it's impossible to outgrow, meaning Elastic Beanstalk automatically scales your application up and down based on your application specific need using easily adjustable auto scaling settings. So that's really good, meaning that it's impossible to outgrow, meaning when it comes to EC2, you are given a container and it's your responsibility to utilize it in the way that you use you use it to the full value of it. Meaning that, for an example, if you take 4 gigabytes of memory, and if you're only using 2, then it's you're paying for what you're paying more for what you actually use. So that's really not that good. So Elastic Beanstalk, what it actually does is it automatically scales your application up and down based on your specific need. So it's easily adjustable auto scaling settings are there. And complete resource control. So this is one thing, this is the most important thing that differs from Lightsail to Beanstalk, because you have complete control over the resources. You have the freedoms to select the AWS resources such as Amazon EC2 instance type, like I mentioned, and the processor type to run the workload on that are optimal for your application. So that kind of customization is not there on Lightsail. So if you need that kind of customization, you will have to move your application to the instance to your to EC2. But in Elastic Beanstalk, it's not like that. It's just basically have all these AWS services that use it behind, so that you can configure everything atomically. So that's what it does. So if you need more customization, it's better to go for Elastic Beanstalk rather than Lightsail. That will be mentioned in the next slide. So yeah, and the best thing about this is it does not take any extra price at all. Elastic Beanstalk, if you use it, then you are actually paying for the resources that you are actually using. So let's say that you are using particular EC2 instance type, then you are paying for that, not for the Elastic Beanstalk. So that's really great when it comes to Elastic Beanstalk. And comparing between these two, Amazon Elastic Beanstalk and Amazon Lightsail, if you need more flexibility on configuration, go for Elastic Beanstalk, just like I told you. But if you just want to run a simple application in the cloud, Lightsail might suit your need. So I don't think I have to explain that uh, uh, this sentence at all, because it's pretty straightforward. Okay, now that's the end of the first half. Now we will look at the second half of it, the serverless version. So in the last session, Binda has told that at the beginning of the presentation what actually is serverless computing. So people have this myth saying that serverless is actually that there's no server. So that's very wrong. There are servers. You just actually don't have to manage it. So that's what serverless is. So the last week's presentation started with that huge heading where serverless doesn't mean that there is no servers. It just means that you don't actually have to manage. So these are the serverless architecture. So when it comes to EC2, I have told you that you have to worry about your scaling and have to worry about your security, operating systems, and all this infrastructure aspect of it. Not physically, it is very easier than having to manage it physically, but still you have a little bit of overhead there when it comes to managing your servers. So what this does is when it comes to serverless offerings that AWS has, you actually don't have to worry about those at all. So AWS Lambda is a serverless compute service that runs your code in response to events and automatically manages the underlying compute resources for you. So uh, AWS Lambda is a serverless compute service. So you may have heard about AWS Lambda because it's becoming very, very popular these days. So AWS Lambda is like a small function that bundled up together. So when you are working with micro services architecture, AWS Lambda plays a big role in cloud computing. So when integrating that into microservices, so it runs code without provisioning or managing infrastructure. That's what basically AWS Lambda does, and it automatically responds to code execution request at any scale. So that is uh, one of the beautiful things about AWS Lambda, where it can run on any scale, meaning not the computational power, but if you get more traffic, it can scale up as you want, as it is necessary to accommodate all this huge traffic. But it will be costly, of course, but it can scale up and scale down at any scale. So pay only for the compute time you use. So so that is really great. That is an on-demand service. Like you only pay for the computational time that the Lambda uses. So you don't. So if Lambda is deployed and you're not using any Lambda, you will not actually have to pay for that. So, and Lambda runs your code on a high availability compute infrastructure and performs all the administration of your compute resources. So you don't have to worry about the server infrastructure at all. You just have to worry about your application code in when you are using Amazon Lambda. Yes. So let's have a look at a very basic example of how to use this AWS Lambda. So make sure, just to keep in mind that AWS Lambda is not like a full-on application. It's a basic. It can be a full application if the application does only have one functionality, just like this. So let's say that you are taking a photograph using a DSLR camera or a high resolution camera, and you need to put that photo into a phone. So you need to resize it, right? And resize it as to the screen of the phone. So that's what you need. So we can write a code, simple code to do that using any of the languages that you know. So when we are using Lambda on top of this, so let's look at this diagram. Your photograph is taken, and then this photograph can be put into this Amazon S3. So S3 is a simple storage service where you will, it's like a storage service. It's like a little bucket that you can put stuff in and then take stuff out. So that's basically it. It's actually called S3 bucket, if you see here. And you will get to know about Amazon S3s in the next episode of this webinar series, where we talk about storage services that AWS offers. This photo is uploaded to an S3 bucket. And then as soon as a photo is uploaded into this S3 bucket, you can trigger a Lambda. You can ask this, you can have a code inside this Lambda to resize it. Then Lambda runs the image resizing code. Then it sends the response out, the resized photo actually. the photo is resized into web, mobile, at tablet size. So it's pretty very basic. You actually don't have to worry about any server management, security, or anything at all. AWS Lambda does all that behind. So it's really straightforward, and really helps a lot when it comes to uh, using AWS in without having to worry about this infrastructure. And then we have AWS Fargate. It's basically like AWS Lambda, but for containerized applications. So deploy and manage your applications, not infrastructure. Fargate removes the operational overhead of scaling, patching, securing, managing servers. So this is also a serverless offering that AWS provides. But it's so the AWS Lambda that we talked about is more towards function as a service, FAS, if you're familiar with it, and AWS Fargate is more towards containers as a service. So uh, this does not handle only one function. You can actually deploy a full-on containerized application using Fargate with the serverless architecture. So you don't have to worry about your servers at all. So deploy and manage your applications, not infrastructure. Fargate removes the operational overhead of scaling, patching, securing, and managing servers. And you can monitor your applications via built-in integrations with AWS services like Amazon CloudWatch and Insights. So you can use this to monitor your Fargate applications, and then improve security through workload isolation by design. So this is one of the most important things when it comes to Fargate. It has a default option of workload isolation that is there by design. So you don't have to worry about having separate VMs, virtual machines, in order to isolate between your applications. So inside Fargate instance, you can Fargate container, you can actually this isolates between each application by design. And you can only pay for what you use. So Fargate scales the compute to closely match your specified resource management, resource requirements. So with Fargate, there is no over provisioning or paying for additional servers. Just like I mentioned with the server full architectures, just like EC2, you actually don't have to worry about over provisioning, meaning that not utilizing the entire content that you are paying for. You don't have to worry about that in Fargate, because it scales down when necessary and scales up whenever there is a need. So you don't have to worry about over provisioning or paying for additional service. So the difference between Fargate and Lambda, you might be wondering what it is. So just like I mentioned, Fargate and Lambda basically does two things. So while even though both of these are serverless offerings that AWS offers, while Fargate is a container as a service, CAS offering, AWS Lambda is a function as a service, FAS offering. Therefore, Lambda functions do not necessarily need to be packaged into containers, making it easier to get started with Lambda. But if you have containerized applications, Fargate is the way to go. So this is a pretty basic level of comparing between Fargate and Lambda, but there are so many things when it comes to choosing what actually is the best solution for you, depending on the use case. For an example, I can tell you Fargate takes a little bit of more time than Lambda to spin up, but Lambda takes very little less time to spin up. So Fargate actually can take 1 minute or so to be fully up and running, but Lambda can take very little time. But then again, Lambda has very little computational power, 4 gigabits of RAM, but Fargate can have a lot more than that. So there are ups and downs when it comes to Fargate and Lambda. So this is the basic difference that I have mentioned here, but it depends on the use case, what to use and what not to use. So with Fargate, you can see how easy it is. So without Fargate, you have to build your container images, define and deploy the EC2 instances, provision and manage computer memory resources, and isolate applications in separate VMs. This is important, and run and manage both application and infrastructure. So you have to pay for the EC2 instances as well. But with Fargate, it's not like that. So steps are very reduced. The overhead is reduced. So you can define memory, compute resources required, run and manage only the applications. You don't have to worry about the infrastructure at all. And then isolate applications in separate VMs is also removed because it is there by design. So pay for requested compute resources when used. You don't have to pay for your EC2 instances, or you don't have to pay for like allocated services in the gate like beforehand. You only have to pay for what you have already used. Application isolation is by design. Okay, then we have the question. We have earlier we looked at AWS Fargate or AWS Lambda. So that is a big question that is there nowadays. And also there is this question where what to use when it comes to EC2 or AWS Fargate. One is serverful and one is serverless. So what to use is bit of a question as well. So on the top of your head, you might be thinking, why do we use EC2 at all? Uh, because we don't actually have to worry about servers or infrastructure, managing infrastructure at all when it comes to AWS Fargate. So when to use it at all. But there are some instances or use cases in our life where we have to use EC2 instances. We can use Fargate on those instances, but the most optimal solution would be to use EC2. So we'll have a look at that. In the first one, you can see when there is a large workload, but you want to optimize it for the price, then the best solution would be to go with EC2. So if you read this description, if your workload has a consistent demand for many CPU cores and many gigabytes of memory, then your traffic and computational power becomes, if your traffic and computational power is predictable, then you know what you are signing up for. Then if you can utilize it properly, the EC2 instance, I think it's best to go with EC2 if you have a large workload. Then you can utilize it more. And also when it comes to pricing, Fargate is a little bit of more expensive because EC2 can have this spot instances or reserved instances. So these are two types where you can buy EC2 instances. One has a discount and the other one gives you the option to bid for your instance. So both of these will save you money in terms of buying an EC2 instance. So without having to use Fargate, you can use an EC2 instance in this case if your traffic and computational power is predictable. Then you can manage properly, and also you can optimize the EC2 instance properly. And then we have the large workload optimized for low overhead. In this case, I think it's best to go for AWS Fargate because managing a large cluster of EC2 instances can be somewhat hard. You need to make sure that they are all patched, secured, updated to the latest version of Docker and ECS agents. If you don't want to deal with any of this overhead, AWS Fargate can be a great choice. So for an example, if you see a security vulnerability in one of the libraries that you have used, then as soon as a patch is out, you will have to go and install this patch into every single one of these EC2 instances in the cluster. So that's a huge overhead, and it can be a little painful as well. So when it comes to AWS Fargate, it's not like that. The AWS engineers will do it for you. The patches and automatic security patches will be installed automatically, and you don't have to worry about these security patches, updates, and everything. That was just an example. So in this case, it's best to use AWS Fargate. And also, if you have small workload with occasional burst, let's say that you are experiencing a high traffic in daytime and low traffic in nighttime for your application, then it's best to use AWS Fargate. Because if you scale up during the daytime, and if you don't scale down during the night time, you are paying for more computational power that you are not actually going to use. So that itself is a bit of a over provisioning, and you are paying more for what you are using. So so that's where AWS Fargate is necessary, where it can automatically scale up and down with the demand that your application is going to get. And if you also have a tiny workload for a small test environment, AWS Fargate is the perfect fit because EC2 instances are generally too powerful. So if you don't want to, if you don't see the necessity, and if you don't see yourself optimizing the EC2 instances properly, with that much of computational power, then it is not really necessary to go for an EC2 instance. You can go for AWS Fargate. And also, if you have batch workloads, let's say cron jobs like backing up at 1 p.m. every day. So if you have like scheduled jobs like that, then you can easily use AWS Fargate because whenever that you are not using this particular instance, then you can actually the charges will not be there. But if you use EC2 instances, then you have to start and stop whenever to actually to manage your EC2 instance properly, and then to save you the cost that is required. But AWS Fargate, you don't have to manually do that. It automatically does it, and then you will be only charge you for, they will be only charging you for the computation that the time that it is up. So EC2, Fargate, Lambda, when comparing these two, I think this is a very good chart made by Simform, where EC2 gives the most operational burden, but it will give you the most flexibility as well. Because in the configuration wise, when you are dealing with huge number of traffic, and if the traffic is if traffic is very high, then you might need to configure each of these instances properly. Then in that case, in industry level application, I think it's good to use EC2 because it has the most flexibility. And Lambda, when it comes to Lambda, it's least operational burden, and it's also the least flexibility, because nowadays it gives a little bit of flexibility with services added on top of that. But Lambda used to be very fixed, and you don't get that kind of flexibility. You didn't used to get that kind of flexibility in AWS Lambda, and Fargate sits in between these. Yeah. Okay, so let's move on to Aprana. So this is another AWS service where it adds a abstraction level on top of the Fargate. So when it comes to AWS Aprana, is a fully managed service that makes it easy for developers to quickly deploy containerized web application and APIs at scale with no prior infrastructure experience required. Meaning that, so I told you, even for Fargate, you don't need that kind of infrastructure knowledge. You actually have to have very little knowledge, and you don't actually have to manage all of these servers in the atomic level. But still, there is a little bit of work to do in infrastructure level in Fargate. That is also, even that is reduced in AWS Aprana. You actually don't have to have any prior infrastructure experience when you are deploying containerized application or APIs using Aprana. So this is becoming very popular these days because because of the way that AWS growing right now, and there are so many newcomers, there are so many new users looking for a way to deploy their APIs or containerized applications, web applications. So this is becoming very popular now. With Aprana, you just have to add a source, connect to your source code or container image, and select deployment settings. Then configure build and service settings, review and create. Then you will be receiving a secure URL. It's simple. It's very simple. You don't have to worry about any infrastructure at all. So yeah. So with AWS Aprana, it's very easy to use. It scales with traffic. You don't have to worry about it. The auto scaling is there, and it saves time. Just like I mentioned, you don't have to worry about infrastructure at all. Then you can focus on your application development. So it saves time, saves a lot of time, and ensure compliant environment as well. So this will generally create a compliant environment for your web application, meaning that the libraries and everything will be installed, and the environment will be set for your application. So Aprana does all that. Lastly, we will look at Amazon Elastic Kubernetes service. So I will not go much deep into this. This is also, if you are a Kubernetes enthusiast, if you are using Kubernetes to create your applications, then you can easily use this. What it does is you can create Kubernetes clusters using Amazon EKS, and then you can deploy this using either with serverless approach or serverful architecture, with meaning that you can deploy it with AWS Fargate or AWS Amazon EC2. And then you can run your Kubernetes apps through one of them. Then Amazon EKS dashboard in the AWS console will show you a proper dashboard of it, like the insights and explore the running Kubernetes apps. So this is pretty much the summary of AWS Compute Services. There is a lot more than what meets the eye in AWS, because you have to dig deep if you're properly studying AWS. This is just a basic understanding to make you comfortable with these words and make you not get a fright when you hear Amazon EC2 or AWS Lambda, whatnot. So this is just a basic understanding of each one of these. Uh, uh, yeah, in the next few two episodes, we will also hear about the storage services that AWS will offer, and also the app integration that the AWS offers. So yeah, if you have any questions, you can direct me now.
Yeah, so yeah, if you will be starting the Q&A session now, so if you guys have any questions, you all can drop them on the chat or even to the speaker personally as well. Yeah, so it looks like we have no questions at all. And it's time up as well, so 3 minutes to 6. So if you guys still have a question, y'all can drop it as well. So yeah, I'm sure like most of us must have learned something new today, like, and got a very good understanding of the AWS Compute Services, like EC2, AWS Lambda, and AWS Fargate, and etc. So, and I also believe the comparison between the common AWS services was really detailed and gave us a really good understanding on like what service to use when, like depending on the situation. So it looks like we have no questions at all, and we can wrap things up. So now I would like to take the time to thank Rahal Madhwata for accepting our invitation and taking a bit of time of his very busy schedule and sharing his knowledge with all of us. And it was really helpful to get an idea of AWS Compute Services. So the next webinar in this series will be happening in a couple of weeks' time, and it will be regarding the data store services. And I hope to see you all there as well. And also don't forget to keep in touch with our social media platforms for the registration links regarding the future sessions. So I think we're good to wrap things up since there's no any questions.
Yeah, thank you very much, Ishrat. If you have any more questions, you can directly reach out to 99X, or directly reach out to me as well. So if you further find any questions.
Yeah, feel free to email us if you have any questions regarding this webinar. Also, yeah, thank you once again, Rahal, for the invitation, and thank you all for joining, and take care.